For the next couple of days, we are going to be concentrated on the Pythagorean Theorem. And the Pythagorean Theorem says that in a right triangle, so this only works for right triangles, if you take the two legs and square both of those values and add them together, that will equal the length of the hypotenuse squared. So a squared plus b squared equals c squared. A and B are the legs, so the two shortest sides, and C is the hypotenuse, which is the longest side. So for example 1, it says to find the value of x, give your answer in simplest radical form. So we have to use the a squared plus b squared equals c squared. So c is always the value across from the right angle, and it's always the longest side. So this is our c, so we don't know what c is. The other two sides are A and B, and it doesn't matter which one's A and which one's B for this one. The only one that really matters is the C. So if I plug in the numbers, we have 6 squared and 4 squared and C squared. So 6 squared is 36, 4 squared is 16, and then C squared. And then if I add those two together, I get 12, 40, 52, equals c squared. Now we want to know what c is, not c squared. So to cancel out squared, we're going to take the square root of both sides. So that cancels that out. So I'm going to move over here. So c equals the square root of 52. So now I have to figure out how can I break up 52? And remember, we have perfect squares. Those perfect squares would be 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And the list goes on, but those are all of them from 1 to 100. So I'm going to look for one of those numbers that I can divide 52 by. Well, the only one is 4. So 4 times 13 is the same as 52. I can take the square root of 4, that's 2, and then I have the square root of 13 left. So that's what they mean by simplest radical form. So you might want to write this list down because those are the numbers you're looking to divide by when you're trying to simplify your radical at the very end. All right, so C is 2 square roots of 13 in this case. Now for this one, again, across from the 90-degree angle is our C, and the other two are A and B. So A squared would be 5 squared. B is x minus 1, so we have to square that, equals C squared. Or in this case, x. So we have the same variables. 5 squared is 25. And then we have to do x minus 1 squared. So what that means is x minus 1 times itself. So we have to FOIL. So first would be x times x, which is x squared. Outside, negative 1 times x is negative 1x. Inside, negative 1 times x would be negative 1x. And last, negative 1 times negative 1 is a positive 1. Now we combine like terms. So the negative 1x's can go together. So we have x squared minus 2x plus 1. So that goes over here because that's x minus 1 squared. So we have x squared minus 2x plus 1. And that equals x squared. Now we have x squareds on both sides. So I'm going to minus x squared to move them to the same side. They're both positive, so the opposite would be to subtract. What that does is cancels them. So we have 0 here, and then I can combine like terms in this step as well. So 25 and 1 go together, so that's 26. And then I have a minus 2x. So then I'm going to subtract 2x, or 26 from both sides, and I'm going to have a negative 2x equals negative 26. And then I'm going to divide by a negative 2. So a negative divided by negative is positive, and 26 divided by 2 is 13. So the c value, or the x value in this case, is 13. All right. Example 2 says to prevent a ladder from shifting, safety experts recommend that the ratio of A to B be 4:1. How far from the base of the wall should you place the foot of a 10-foot ladder? Round to the nearest inch. So we want this value here, where the B is. So we are going to use the formula A squared plus B squared equals C squared, since this is a right triangle. And they're saying A has to be 4 times the size of B. So we are going to have 4, we'll call it x, 4x squared. And then B would be x squared if we just use the same variable. So A is 4 times the size of B. So that's why we have 4 times x out front for the A value, and then x squared. And they're telling us that the ladder is 10 feet. So this would be 10 squared here. So now I have to simplify. So 4x squared, when I have a exponent out front, I have to distribute it to both things inside. So 4 squared would be 16, and then x to the second power is x squared, plus x squared equals 100. Then I can combine like terms. So I'd have 17x squared equals 100. And then I'm going to divide by 17. So I'm going to have x squared equals 100 over 17. And then I don't want to know what x squared is. I got to cancel that squared. So I have x equals the square root of 100 divided by 17. So when I do 100 divided by 17 and take the square root of that, I get x equals 2.4, and that's rounded to the nearest tenth. They say to round this to the nearest inch. So the 2 represents the feet. So we have 2 feet, and then 0.4 is 4/10, and 4/10 is 2/5. So we have 2/5 of 12 inches, and of means multiply in math. So 2/5 of 12 is 4.8. So that means 4.8 inches, and that to the nearest inch would be 5 inches. So 2 feet, 5 inches. All right, Pythagorean triple is a set of 3 non-zero whole numbers. So they can't be 0 and they have to be whole. A, B, and C when A squared plus B squared equals C squared. So example 3 says find the missing side length and tell if the side lengths form a Pythagorean triple. So I have to do, I have to figure out which one's A, B, and C. So across from the 90-degree angle will be C. The other 2 are going to be A and B, whichever one you pick. So I don't know what A is. B is 12, and C would be 15 in this case. So A squared plus 12 squared is 144, and 15 squared is 225. And then upside down T, we're going to minus 144 from both sides. So 225 minus 144 is 81. And then we have to take the square root to cancel the square. So A is 9. So our 3 sides are 9, 12, and 15. So our 2 qualifications here, they are non-zero, so not 0, so that's good, and whole numbers. And those fit that, so yes. That's a Pythagorean triple as well. So for this example, again, across from the 90-degree angle is our C. So the other 2 would be A and B. So 15 squared plus 9 squared is equal to C squared. 15 squared is 225, and 9 squared is 81. And that's going to equal our C squared. 225 plus 81 is 306. And then I have to take the square root of both sides to cancel out the squared. So C equals, and going through the list of perfect squares, 306 can be divided by 9. So it is actually 9 times 34. And the square root of 9 would be 3, so that goes on the outside, and then we have 34 left. 34 cannot be divided by anything in that perfect square list, so that's as far down as we can simplify that. So C equals 3 square roots of 34. So our side lengths are 9, 15, and 3 square roots of 34. So going through our 2 check marks, not 0, it passes that one's good. And then whole number is the other one. And 3 square roots of 34 is not a whole number. Remember, a whole number is a number that you would say when you counted, and we definitely don't have that in our list when we're counting. All right, the converse of the Pythagorean theorem says if the sum of the squares of the lengths of 2 sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So if the sides work in the Pythagorean theorem, then we know it's a right triangle. Before, when I told you to use the Pythagorean theorem, I said it only works in right triangles. So this is flipped around. That's why it's called the converse. It's telling us if it works in the formula, then it is a right triangle. And then the inequality theorem says that if c squared is larger than the other 2 sides squared added together, then a triangle ABC is an obtuse triangle. We have an obtuse angle. And if c squared is smaller than the other 2 sides squared added together, then our triangle is going to be an acute triangle. So we need to decide if these measures can be the side lengths of a triangle, and if so, what kind of triangle. So we are going to plug them into our formula of a squared plus b squared equals c squared. So the 2 smaller sides are going to be your a and b. 8 squared is 64. 11 squared is 121. And 13 squared is 169. And 64 plus 121 is 185. And 185 is larger than 169. And if that's the case, the 2 sides added together is larger. So that's this one where the alligator mouth is open towards that one. So that means those 2 sides are bigger. That's what happened here. So this is an acute triangle. Now, the other thing you want to do is to make sure that when you add these 2 sides together, it's going to be larger than the third side. So 19 is greater than 13, so it definitely can be sides of the triangle. So this is an acute triangle. And when I do this one, 5.8 squared plus 9.3 squared equals 15.6 squared. I end up with a result of 120.13 is less than 243.36. So the c squared value is larger this time. So that means it would be an obtuse triangle. But when I check here, when I do this 5.8 plus 9.3, that should be larger than 15.6. And when I add those 2 together, I get 15.1, and that is not true. So these are actually not a triangle. So I want to say not a triangle. They can't be side lengths of a triangle. You cannot construct a triangle with those side lengths. If that worked out, then it would be an obtuse triangle, because this part works out just fine, but this part does not. So always check that first, and that was my mistake here. So for this one, 7 plus 12 is 19. 19 is larger than 16. So 7 squared plus 12 squared equals 16 squared is going to be 93